So in this MathByte, we're going to introduce a concept that's very important in physics called the vector. Vectors are a kind of mathematical quantity that happen to have the exact right properties to describe a lot of important physical quantities like position, force, momentum, and acceleration. And so in this video, we'll introduce what vectors are and talk about how we can represent vectors graphically, or in other words, with pictures. So before we get into that, we need to talk about what it means to have like categories of mathematical quantities, right? Most numbers we think about in math classes are secretly a kind of quantity called a scalar. Scalars are fully defined by just their size, and that's it. So for example, the number 3 is a scalar that has a size of 3. And the number 5 is a different scalar that has a different size, right? That makes it not the same as the number 3. And I am fully aware how silly it sounds to get this specific about numbers, but this is important for understanding the difference between vectors and scalars. Vectors, on the other hand, are mathematical objects that have both a size, which we call the magnitude, and a direction. And so this direction part of the definition of a vector is the distinguishing feature between vectors and scalars. For example, a number like temperature can be represented by a scalar. To fully describe a temperature, all I need to do is provide the value I read off a thermometer, right? Like 21 degrees Celsius. There's no conceivable idea of temperature in a particular direction. You would never hear anyone say 21 degrees to the left or to the right or up or down, right? That direction is completely meaningless. On the other hand, a quantity like a force needs to be described by both a magnitude, in other words, how hard I push, and which direction I'm pushing a thing. If I just tell you I'm pushing on an object with a magnitude of 25 pounds of force, I haven't specified whether I'm pushing left or right or up or down, and therefore I haven't fully described the force that I'm pushing with. You don't know everything about that force. Before we go any farther, let's pick a physics vector quantity that's nice and intuitive to think about. Let's pick the displacement vector. The displacement vector is a vector in physics that describes the difference between a starting position and an ending position. So for example, imagine there are two spots on our sheet of paper. There's position A and position B. If I walk from A to B, my displacement vector describes my change in position, and it starts from A and goes towards B. So we might draw an arrow that starts from A and goes towards B, like this. This picture of an arrow is what we call the graphical representation of a vector. It has a start and an end, which shows us what direction the vector goes in, and the length of it gives us the exact magnitude. In our case, the direction of this displacement vector points from A towards B, and it's exactly long enough to get us from the first point to the second. I could also represent this vector algebraically, or in other words, with an algebraic symbol, in case I need to use it in equations. Let's call this one XAB. I chose the letter X here because it's usually used to represent distances and lengths in physics. You can really call this whatever letter you like. You could just call it vector A if you wanted, or vector V. The important thing is that you make sure that the reader knows that it's a vector by adding a little arrow over the top. That way we can distinguish it from different scalar values. And so just so we can look at some other vectors, let's draw a displacement vector that goes from B to A. I might call this vector XBA, once again with a little arrow on top to show that it's a vector. And just by looking at these vectors, we can tell that because they go between the same 2 points, they have the exact same magnitude. But the arrows are pointing in different directions, right? So we know that the directions are not identical, and therefore these vectors are not the same. In fact, we could describe vector XBA as pointing in exactly the opposite direction as XAB. We can also draw another displacement vector that goes halfway from A to B. Something like this. This vector has the same direction as the first vector, right? We're still going from A towards B, but we only made it halfway, so this vector only has half the magnitude. And so we can see how these graphical representations make it really convenient to make quick visual comparisons of different vectors. These arrows are often how we graphically represent vectors in physics. We use these pictures to represent vectors because vectors have a lot more information than scalars, and we can't really capture all this information in just a single number, like we can with a scalar. The last property I want to talk about in this video is that vectors are fully represented by direction and magnitude, and they don't care about where they are in space. In other words, if we have two vectors of equal length and they point in the same direction, then they're the same vector, even if I draw them separately from each other and on different parts of my sheet of paper. It doesn't matter where the starting location is. All we care about when we're evaluating whether vectors are the same are the magnitude and direction of each vector. Okay, that's really all I have to say for this intro on graphically representing vectors. And so as per usual, let's summarize some of the things we saw in this video. First, some quantities in physics, such as displacements or velocities or forces, have both a size and a direction. These are called vector quantities. Secondly, vectors can be graphically represented by arrows. The direction of the arrow shows us the direction of the vector, and the length of the arrow tells us the magnitude of the vector. Third, we can also use algebraic symbols to represent vectors, but in order to make sure that we know that these are vectors and not scalars, we add a little arrow over the top as a reminder. And finally, graphical representations of vectors can be used to visually compare two vectors. We can really easily tell just from these representations whether two vectors are going in the same direction or have similar sizes just by comparing the graphical representation of the vector. Earlier, we spent some time outlining how vectors are different than scalars. However, vectors are still mathematical quantities, and they're useful in physics because they represent physical quantities that can be added together, subtracted from one another, and be equal to each other, just like scalars. However, because vectors have more information than scalars, the rules for how to add and subtract vectors are a little more complicated than the regular old addition and subtraction rules you might have learned in math class. And so in the next video, we'll look at how we can use these graphical representations to do some of these mathematical operations like addition and subtraction, and even multiplication. But for now, we'll leave things here. Remember, if you have any thoughts or questions you'd like to share, please leave them down in the comment section below, and I'll try to get to them. And don't forget to like and subscribe for more free physics problem-solving tips. This has been Physics Tutoring Quantized.